Hey guys, good morning. Welcome to the flight analysis class. Today we are going to discuss about the limiting case for large load factor. For large load factor, what is the limiting case? In last three classes we have discussed about what is the level turn, what is the pull-up maneuvering, what is the pull-down maneuvering. In three cases we have solved two things. One is turn radius and turn rate. In this thing, the main parameter of conditions involved is load factor. The load factor is the ratio between lift of the aircraft to the weight of the aircraft. So, in a large load factor case, that is N is very large unit value. So, this is the case indicating the large load factor. Let us take these three cases. One is level turn. Next is pull up condition, pull down condition. So here the turn radius R will be V infinity square divided by G root of n square minus 1. For this pull up condition, turn radius R equal to V infinity square divided by G n minus 1. For pull down case, turn radius R equal to V infinity square divided by G n plus 1. So these are the things we have derived in the last class. Similarly, for turn rate omega, we have got this G root of n minus n square minus 1 divided by V infinity. And here we are getting for the pull up condition, we have got G n minus 1 divided by V infinity. And here pull down condition, we got omega equal to G n plus 1 by V infinity. For all these 6 cases, like turn radius is 11, turn rate, for pull up condition, what is it? Turn radius and turn rate. For pull down condition, what is it? Turn rate and turn radius. Here, the main thing is involved in all the 6 equations is load factor rate. If the load factor is large compared with the unit value 1, the entire equation turns as for level flight, that is V infinity square divided by G here. Very large into N. For this case also V infinity square by G into N. For this case also V infinity square by G into N. And coming to turn, this is a turn radius. Turn rate omega will be here also N, this unit value again G N by G N by V infinity square. For all the cases. So this two equation help us to understand for any aircraft by limiting the large load factor which resides in the turn radius value as well as the turn rate value. So R equal to V infinity square by Gn, omega equal to Gn by V infinity square. From this for any aircraft, so here the end involves L by W. So for any aircraft, weight is a constant value, whereas lift is very parameter. So let us take the lift equation is equal to of rho infinity, rho V infinity square from CL. So the lift equation of rho infinity S into CL. This is the lift equation. From this equation, we can find out what is the V infinity. That V infinity helps us to understand what is the turn radius and what is the turn rate for all the conditions. So from this, we can get V infinity square is equal to 2L rho S into C. This V infinity we can substitute in the turn radius equation and we can rearrange the equation. We will get the turn rate as well as the velocity. Similarly, V infinity is equal to root of 2n divided by rho S C. These two things we can substitute here and we can resolve it. Now we can substitute the V infinity square value in the turn rate is R equal to V infinity as we can replace 2L divided by rho S CL whole divided by G that you can add here into N. This is the load factor rho S CL G. This load factor will be L by W. You can cancel this L, this W will go up. So 2W rho S CL into G. This is the term radius in the limiting load condition. So now the turn rate, we can solve the turn rate. Turn rate omega equal to turn rate similar for the turn rate is omega equal to Gn by V infinity. So Gn V infinity will be root of 2L rho S Cl. So rearranging this as, so M is load factor G. So we can rearrange this equation as rho S Cl 2L. This N will goes inside things, that will N square. Is that right? This is N square, right? So we are getting G root of rho S Cl is a load factor L square by W square whole divided by 2L. This L and this L will get cancelled and this W square will come out. So we can write this equation as omega equal to G by W root of or else we can write it as in a different way. By saying this is load, wing loading W by S rho S Cl, this lift divided by 2 W, that is load factor into W. So omega equal to G rho Cl lift divided by 2W is by W. This is load factor. This is the limiting load factor or large load factor, that is a turn rate. We can rearrange this equation in simplified manner. So W equal to G. So here rho Cl, this L by W is a load factor, that is the N, you can put it here. 2 times of W by S is a wing loading, so we can write this as a W by S is a wing loading. This is a turn rate for a simplified way, right? But from this equation, from this two equation, we can infer that if the turn radius, if the aircraft is either in level turn or the pull-up maneuvering or the pull-down maneuvering, if the turn radius should be minimum, small distance, what if it is a turn level turn or pull-up maneuvering or pull-down maneuvering? If the turn radius is minimum, this Cl will be max. Once the turn radius is minimum, this Cl will be max. Similarly, if the turn radius is minimum, this wing load will be max. The turn radius is minimum, the wing loading will be max. So, from this equation and derivation, if the limiting case, if the load factor is larger, all the three cases, level turn, pull-up maneuvering, pull-down maneuvering, we are inferring that if we want to flight should be turn at the minimum radius, the shear should be max. Similarly, the minimum turn rate achieved only with the wing loading will be max. Thank you. We will see in the next class.